Hello viewers, welcome back to my YouTube channel. In today's presentation, we are going to be looking at an exercise that appeared on the first semester examination paper, January 2025, Area Analysis 1. It was given to the students of the Faculty of Engineering and Technology, University of Goya. And also, whether you are doing which university course, come and gather here. All of you should come and gather here, because while watching this video, you will learn some things or recall some things that you have already forgotten. And also maybe you will come across new techniques in handling certain problems. This is a crazy solution review. If you are new to this channel, kindly hit the subscribe button. This button you're seeing right here, hit it. When you hit it, it will now show subscribe with a Z at the end. And don't forget to turn on the notification bell so that whenever new content are uploaded, you will be the first to be notified. And make sure while you watch this video, you share it to others. Like the video, share it to your friends so that they can also benefit from whatever you're going to benefit. Okay, this video is going to be very helpful to all of you. Remember, real analysis, you carry it throughout your life. Real analysis, okay, the knowledge you gain from real analysis 1, you have to apply it in real analysis 2 and measure fields in your studies. Okay, now let's look at the problems. The very first problem that we have there, we have this one, okay? This inequality that you are seeing right here displayed. The absolute value of x plus 2 plus the absolute value of x minus 2 is less than 12. Students were asked to solve this problem for 5 marks, okay? Why this one? This is what fractional inequalities. I will show you what to do and what not to do in solving this type of exercises. Okay, so like I said, I am Temgun 48 presenting this script. Okay, so without wasting much of your time, can we get started? Of course, let's get started. So the very first question, I will just read it as it was given on the paper. It says that let R denote the set of real numbers. This is just a subsection of exercise 1. There are other Roman numerals that follows, but Roman numeral 1 is our focus of this in this video. Okay, so students were asked to solve the following inequalities, where the first one was the x plus 1 divided by 2 minus x is less than or equals to x divided by x plus 3. This is practically a rational inequality. There are various ways to solve this, but I will show you the easiest way it is being done. Okay, follow up and you will learn. Second question, as we have seen in the introductory part, we have this. And also, please, if you are watching this video, make sure you watch alongside with a piece of paper, so that whatever activity I'm going to be doing here, you will do exactly the same thing to easily keep the information and also practice it. Okay? Because if you are just watching the video without doing the calculation, this is mathematics. There is no magic here. If you are just watching the video without doing the calculations, then practically you will actually be wasting your time, because you can grab just a minimum of 1%. Okay, psychologists have proven that. Okay, mathematics is all about solving, and you must do it by yourself. Don't just hear that this man said that. No, it's not enough. Even if you grab the information that time, you will likely forget it. unless you are actually, a pro in the course. Now, we are going to begin with the first exercise that says that the x plus 1 divided by 2 minus x is less than or equals to x divided by x plus 3. How do we solve this? This is a rational inequality. Don't make that mistake to cross multiply, okay? Because you don't know the sign of 2 minus x, you don't know the sign of what? X plus 3. You are not sure they are positive or negative, or it varies. Okay, so don't do that mistake. What we'll do is this: we'll gather all the terms on one side. This term will cross the inequality sign. When it is crossing the inequality sign, it just changes. In other words, we are subtracting both sides of this equation by what? X over x plus 3. We subtract on both sides, so this one will become 0 here. So doing that, we have x plus 1 divided by 2 minus x minus x divided by x plus 3, which is now strictly less than or equal to 0. From there now, we just have to do what? Subtract these two fractions. To do this, we know that the common denominator is the product of the two, right? Okay, so this is a common denominator. So when you take this one and divide by this, it will leave you will be left with what? S plus 3, and you multiply it now with x plus 1, you have this. Or you can just do this times this. Are you seeing it? This times this. That's it there. Minus, if it's addition, you put plus. Okay, minus x times this. X times all of this. Don't make that mistake to put x times. They don't put brackets. You will likely make a mistake there. Okay, so make sure you impose the bracket to show that x is multiplying all of that. The next thing now we have to do is to expand the numerator. So x times s is s squared, x times 3 is 3x, and then 1 times s is x. So that 3x plus this x will give us 4x. I hope you are getting it. Then now 1 times 3 will give us 3. That is the expansion of this. Then minus x times 2 is 2x. Then x times negative x is positive x squared. Okay? Good. The denominator remains the same and the inequality sign does not change because I've not done any manipulation on that. What follows next is to simplify this. X squared plus s squared is 2s squared. Then 4x minus 2x is what? 2x. Then we have plus 3 as a constant. The denominator remains the same as the inequality sign on the right hand side. Following that, we now have to do what? Solve this inequality now that it is in this form. The sign of this inequality, or the boundary regions, right? We want to verify whether this thing, the sign of this inequality, the solution will depend on this guy at the numerator. Remember, we are doing a sign test here. At this stage, we'll do a sign test. To do that, this is a quadratic expression. So I will try to complete the squares of this quadratic so that I will see what I'm left with. So to do that, I have to make sure the coefficient of x squared is 1. How do I do that? I factor out 2. To get the balance, I will need to divide each term by 2. So when you divide by 2 here, you'll be left with x squared. Divide by 2 here, you'll be left with x. Divide by 2 here, I have 3 on 2. Nothing has changed. If you expand this, you get back this. What follows next is to complete the squares of this part. Okay, how do we do x squared plus x? How do we complete the square of that? We know how it is done, right? We simply take half the coefficient of x. So I'm going to write it like this. The 2 remains there. So we take half the coefficient of x, which is half now, and add it. So we just write our x as you're seeing there. Half of this coefficient. The coefficient of x here is 1. So half of 1 is half. Okay. Then now we square it. Sorry, I omitted something here. There is a square here. We square it, okay? There is a square here. Let me just look for a way to put 2 there. So let me take something that will show up. Just hold on a bit. Let me correct that. Even though it's not really clear, but let's use it like that, okay? So now that is that. We now continue with the presentation. So when we take half the coefficient of x, we square it, okay? So we write down our x first, as you have seen. Copy the x, take half the coefficient of x. What is that? It is half now. You square the result. Notice that when we expand this, when we are expanding 2 terms, how do we do it? We'll take the first term square plus the second term square, right? So you see that we have introduced plus 2 times their product. 2 times half will give us 2. I mean 1 times this x will give us this x. But you see now that we have introduced an extra term which was not originally in this form, in x squared plus x. There is now plus 1 over what? 4. Because when you square this one, we'll have 1 over 4. So to create a balance, we subtract 1 over 4 there. Then now plus 3 on 2. Then now this 2 can be simplified further by making this denominator here to be what? By making it to be 2 now, I mean 4. So how do I do it? I multiply the numerator and the denominator by 2. So here will be 6 and here will be 4 now. Since the denominators are the same now, I'll have to now add -1 plus 6, which is 5 on 4. So it's positive 5 on 4. So we'll now write it down like this. Okay, positive 5 on 4. So you see why I say I omitted a 2 here. Okay, that's it there. And then now from there, what do we notice here is that this term is squared. So it is always positive no matter the value of s you input here, whether it's negative or positive. The square will take away the negative sign. Adding 2 positive numbers gives a positive number. So this result is strictly greater than 0. Okay, anything that is positive greater than 0. So clearly, at this point, we have to look at the critical values of this function. It will depend on these 2 values at the denominator. Okay, so it means that when you talk of the critical values, we are looking at points that will create boundaries on the number line. Okay, to get this, we have to equate this to 0 and equate this to 0. We will not consider this one because, remember, we are doing a sign test. We will not consider this one because it's already positive. Okay, since it's already positive, it does not have any problem. What we're interested in is where it is negative. Okay, if it was negative, then we would have considered it. Now that it is positive, let's focus on the denominator. 2 minus x, where equated to 0, we have 2, right? X plus 3, where equated to 0, we have x equals to minus 3. So we have the following critical points: 3, -3, and 2. We now draw a number line and insert these points there. The first point, starting with the lowest, okay, -3 is less than 2. Then we place the second point. Now look at this graph. We have -x times this s will give us -x squared. Since the coefficient of this quadratic, when you expand it, is negative, the coefficient of x squared is negative. So it means that the shape of this graph will take what? An N shape. An N shape. When it is positive, it takes a U shape. For instance, when it's positive here, it will take a U shape. Now that it is negative, it takes an N shape. So insert our graph like that, passing through these 2 points, because these 2 points are the solutions. Okay, We are just showing what will happen on the number line. Clearly, in this region, when look at it at 2, as you are going to the right of 2, the graph is below the x-axis. Below the x-axis means it is taking negative values of y now. So it means that in that region it will be negative. Also here it will be negative. So you have negative in this region because as you are going to the right of -3, the values are what? All negative. That's why it's below the x-axis. Okay, the graph is below the x-axis, so it means it's taking negative values of y, so it is negative in this region. Then above, between -3 and 2, it is above the x-axis. Are you seeing that? It's above the x-axis. So this one now will take what? Positive values here in this region. So like I said, there are negative values here, so you have now positive values in this region. But we will explain why it is negative here, because all the graph in this from -2 going to the right, it is negative. Our interested zone, the inequality sign says it should be less than 0. Anything that is less than 0 means it is what? Negative. Now anything that is less than 0 is negative. So the answer here will be this part, which is correct, is negative. This part is also negative. So the solution set will be this part union this part. Okay, so our solution set to this inequality is just that x is such that in set notation, s is such that s is less than what? -3 union s is greater than +2. So this is the answer to the A part of the problem. Hope you enjoy how it was solved, and I hope you know why we did not consider this, because when we are doing the sign test, we are doing the sign test here. Okay, this function normally you can see clearly that it has imaginary roots, and in the question we were told that x is a real number. Okay, if you solve this one, you have imaginary roots. We will not consider them here. We are working on a set of real numbers. Okay, so and also that's just one point you need to note there. This thing is always positive. Even if this had if this was to have critical values, right, then it would have not been strictly been positive. For instance, you can see clearly when we complete the square here, it is strictly positive in this case. That's why we don't even care about it. We care about the negative sign more. If it was negative, then there would have been a question mark why we should not consider it. Now that it is positive, that is it. Hope it is clear. And also, if you don't understand anything, feel free. The comment section is free. Feel free to express yourself. Okay, feel free to express yourself. Say where you don't understand. You can chat me on WhatsApp. If you don't want to get my WhatsApp number, ask in the comment section and I'll give it to you. I don't want to put it here for security reasons. Okay, if you want my WhatsApp number, ask and I will give it to you in the comment section. Hope you enjoy it. Now let's look at the B part of the problem, which is the most interesting. The question, as you can see there, it looks beautiful, and to some students it traumatizes their brain once they see something like this. They have been used to solving one inequality less than a number. Now that we have two, absolute value inequalities added together, and then it's less than now a certain real number. They just look at the question and they are like, how do we even start? But let me tell you something. It's a secret here that you need to follow. Okay? I will show you the easiest way to solve this problem. The easiest way. The easiest way. So look up. See how it goes. We recall the absolute value of x is equals to what? -x over x. Okay? Absolute value of x takes two values. Okay? It takes two values. -x when x is negative, that's less than 0, and positive x when x is greater than or equal to 0. That's just to show that absolute value of any number, any negative number is a positive. The absolute value takes away the negative sign, because if x is negative here, the negative sign will multiply with the negative x will now be positive. Are you getting that? We'll give a positive answer here, and when x is positive, you just take the positive of it, assumes it. So we are using this definition, okay, to express this and this in their various form. Look at this. X plus 2 will take the place of x, so that will negate this term, negative x, that will be x plus 2, negative of x plus 2, which is negative x minus 2, right? That is only true when x plus 2 is less than 0. And x plus 2 less than 0 is equivalent to saying that x is less than negative 2. I hope you are understanding. Then coming down here, we notice that it is positive when this x is greater than or equals to 0. Okay, so we write x plus 2 is equal to itself only when x plus 2 is what? Greater than or equals to 0. So x plus 2 greater than or equals to 0, when you solve that linear inequality, you just move the negative 2 to the right now. So that will be, the 2 to the right becomes negative. So you have x greater than or equals to negative 2. That's it now. We do exactly the same thing for this part. Same scenario, okay? So this one will take negative of itself. Negative of x is negative. Negative of x minus 2 is for negative x plus 2 now. So you distribute the negative sign. It is negative when x minus 2 is less than 0. That's to say that x is less than 2. And then it takes itself, x minus 2, when x is strictly greater than or equal to 0. So it means that x is equivalent to saying that x is greater than or equal to 2. From there now, we notice that this inequality has some terminal ends. Okay, these two guys have some terminal ends, negative 2 and 2. Those are our points of interest that we use to solve this problem. So we draw a number line, insert the points there, negative 2 and 2 in ascending order. Okay. We notice that between these points, I want to show you how the values, the regions are obtained. Notice this function have values which are less than negative 2, strictly less than negative 2. They also have values which are strictly greater than positive 2. So that's already creating this bound, this region here. Okay, that's the first region. It also has value which are what? Greater than or equals to negative 2, but less than what? 2. Are you seeing that? So that's the next region. It has values which are greater than or equals to negative 2, but less than what? 2. So basically x lies between negative 2 and 2, but negative 2 is inclusive. That's why you put the equality sign there. Also, it has values which are greater than or equals to 2. So it's in this region now. So we'll put the case there. These are the three inequalities, three conditions, three constraints that we'll use to solve this problem with ease algebraically. There is a graphical method of doing it, but I want us to look at it, the solution algebraically. You can easily solve it graphically. If you need a solution for the graphical solution, you can get to me inbox. You can comment it on the comment section. I will reply with a video. Okay, good. So we start with the first case, case 1, when x is less than negative 2. When x is less than negative 2, what is the absolute value of x plus 2? X is less than negative 2, it takes negative x minus 2. We'll come and replace it here. Okay, we'll replace it there. Then now, x minus 2, when x is less than negative 2, it will take this value now, because x is less than 2 here means, so you can also see that we are starting from 2, 1, okay, 0, negative 1, negative 2, and going far to the left. So this this guy is also inclusive inside this region. So the x minus 2, absolute value of that will take negative x plus 2. So I'll write it as 2, that's 2 minus x. It's the same thing now. Yes, I did it on purpose because it was while I was typing, when a positive and negative sign meet, it will show plus or minus. Okay, and I don't want to display like that. So but 2 minus x is the same thing as negative x plus 2. So that's the same thing here. This result is less than 12. Are you seeing that? Are you seeing that? So that at the end of the day, negative 2 plus 2 is 0. So negative x minus x is negative 2x. Okay, that result now is strictly less than 12. Now we have to divide all through by negative 2 to isolate the x. Whenever you are dividing an inequality, okay, whenever you are dividing an inequality by a negative number, are you getting me? By a negative number, the inequality sign reverses. If it is less than, it reverses to greater than. If it is greater than, it reverses to less than. Now that it is less than, the new inequality sign will be greater than. So when you divide here, since negative 2 here, you will left with x. 12 divided by negative 2, you have negative 6. So at the end of the day, we have s strictly greater than negative 6. That's the first case. We now consider case 2. Case 2, we have to consider the regions where s is greater than. I see it, x is greater than, because students often find it difficult to read it. When they say negative 2 is less than or equals to x, it means that s is greater than. Start reading from here. That's how you read this bound. So s is greater than or equals to negative 2. In this region, x plus 2 takes s itself, right? As you can see, s is greater than or equals to negative 2. So it will take itself. Then now, when x is less than 2, this guy, x is less than 2, it takes negative x plus 2. As you are seeing there. So the s will cancel and you are left with 4 less than 12. This case is possible because 4 is less than 12. It is true, but it is of no significance. Okay, in the solution set, we want to look for a set of values of x. This is just what? This is just a fact. Okay, so we move on to case 3. Case 3 is when s is what? Greater than or equals to 2. Sorry, there is an equality sign that has to be inserted there. Greater than or equals to. I will make sure I correct it. Now, when s is greater than or equals to 2, we'll come here. This function, x plus 2, absolute value of x plus 2, it will take which value? S is greater than or equals to 2. It means that we have to consider this region now, because from negative 2 you go to negative 1, 0, 1, 2, 3, and so on. So you see that this region is also found inside here. It's a subset of this. This man is a subset. It's an infinite subset of this infinite set here. So in that case, this guy, absolute value of s plus 2, will take x plus 2. We'll now put it there. Then now, absolute value of s minus 2 will take what? Look at this. S minus 2. S is greater than or equal to 2 now. There is an equality sign there. So it means that it will take x minus 2, right? So s minus 2. And this result is less than what? 12. So now, x plus x is 2x. Negative 2 minus 2 is 0. So you have 2x is less than 12. And then finally, we'll have to divide both sides by 2. Since it's positive, the inequality sign remains the same. So s is less than 2. So I have two constraints here. S is strictly greater than negative 6, but less than what? 6. So it means that x lies between what? Negative 6 and 6. That's the meaning now. Okay, so the solution set is to say that x is such that x lies between negative 6. S is greater than negative 6, but less than a. There is a problem here. It should be a less than. I'll make sure I correct it. So this is less than. Okay. less than 6. I hope this video was helpful. That's the end of this solution. Okay, please, I want to use this opportunity to thank you all for your kind attention, and hopefully to see you in the next tutorial. Please share this video to your friends so that they can also benefit from it. When you share it, and also ask them to subscribe, because that's what will motivate me to create other parts of the presentation of the paper, this first semester reanalysis one that was said by Prof. Agbo-Diodene, your dean, the dean of the Faculty of Engineering and Technology. Okay, he's a mathematician. So that is just it, exactly that. And also, if you want to join my WhatsApp group, Functional Studies 101, you can inbox me in the comment section, request for it, the link in the comment section, and I will put it there. Okay, once I see a request, I'll make sure I reply with the link. So hopefully to see you in the next presentation. Bye bye. Stay blessed. I love you all.